We are live. Hi everyone, welcome back to Code Era. So today is the sixth session for Mastering Game Theory series for CodeForces problem. So let me know in the chat if I am visible and audible to all of you, and then we'll begin ahead within a couple of minutes once everyone else has joined. Okay. Um, if you have joined the stream and I am visible and audible to everyone, just quickly consider giving a like to the video and please give a +1 in the chat so that we can begin ahead with today's session. I'm still waiting for other people. Okay. Hi Sethi. That's great that you have joined today again. So today we have two interesting problems that we'll be discussing. How many problems did you solve of data structures and algorithms or competitive programming? Just quickly let me know in the chat. Please quickly let me know in the chat. Okay. Should I zoom in a little bit more? I think this much is also perfect. I'm just waiting for a couple of minutes for other people to join in, and after that immediately we'll begin ahead with today's session. And today's session is going to be interesting because we are picking up problems that, as you can see, this problem is rated as 1100, but it is a good problem. And another problem that we will be taking is this problem. It is also a good problem and it is a 1200 rated problem. So just quickly let me know in the chat whether we should begin or not, and then we'll be solving the problems today. As you can see, two problems and approximately 30 minutes each for every problem. Okay, hi Ria. Yes sir, 7 question matrix plus. Okay, that is great. 7 questions of matrix, and okay, perfect. So I think that I'll just wait for one more minute for other people to tune in, and then we'll begin ahead with today's session. um Great. Okay, so without further ado, let us begin ahead with today's session. And let me show you the first problem. Let's read the first problem statement. So the first problem statement says that the problem name is Poland ball and game. So this is the problem name for this problem, and it has been given that Poland is playing a game with enemy ball. So there is one guy that is named as Poland ball and another guy is named as enemy ball, and the rules are very simple. Players have to say words in turns. So alternatively, both the players will be saying some words, and you cannot say a word which was already said. So a word which has already been said, you will not be saying that again. Poland ball will be starting first, and the player which cannot say a word first will lose. Okay, the player which will be unable to say a word will lose, and you are given two lists of words familiar to Poland ball and enemy game, and you have to determine who will be the winner of the game if both of them are playing optimally. Is the question clear to everyone? Just quickly let me know in the chat. Is the question clear to everyone? Just quickly let me know in the chat. Is the question clear to everyone? Is this question clear to everyone? Both of them will be having some words that they know. Both of them will be telling those words, and a word cannot be said more than once. So if someone has said a word and another person also knows that word, he will not be saying that word. Okay, clear. It is clear to Ria. What about you, Sethi? Right. Perfect. So let me just quickly copy this test case and see what we can do for this. Also, one more thing, that if Poland ball wins, that is the player who is making the first move wins, then you have to print yes. Otherwise, you have to print a no. Now let me quickly copy some issue? No, it's fine, right? So let us move ahead with this problem and see what we can do with it. Let's say I copy it again, then what will happen? Okay, let us quickly see what the problem statement says. So it says that you both of them are having some words that they know, right? So you can say that for the first player, what is happening? The value n is 5, so the first player knows 5 words and the second player knows one word, right? How do I know that? So you will be given n and m in the first what you will be given, you will be given n and m. So n is the number of words known by the first player and m is the number of words known by the second player. Then after that, n words that the first player knows and input of m strings that the second player knows, right? So these are the 5 words. So one player is knowing one word and another player is knowing 5 words. Who will win? First player will the first player win? And if the first player wins, right, the first player knows this much number of words, 5 words, that is from here to here, and the second player only knows this word. So it is obvious that first player wins, right? The first player wins. So that is what that is that PolandBall wins. That is, you have to print a yes for this case. Is this case clear to you? I hope that it is clear that if the number of words, if let's say if n is greater than m, right, so you will say yes, the first player will win. Or if m is greater than n, then in that case you will say that no, because the second player wins in this case, right? Is this much basic part clear to everyone? Second wins because second is knowing more words. But when can a situation be difficult for us? Is there any other situation? Can you think of any other situation? Any other situation that we should also take care of? In this way, you can see that second word, like if the second one knows more, that is he knows 2 words, so that is why he will be winning. Now let me copy this case as well. Okay. So let me copy this test case as well and then we'll discuss upon this. So the test case is this. Okay. What will you do with this case? Let's say both of them are knowing equal number of words. Then in that case, what will happen? Let's say the n value is equal to m. If that is the case, right? If you know one situation, right? You know this situation. You are also comfortable with this situation. But one more situation can arise, and before that, there is a situation. Let's say both know some common words. Then what will happen? And this is one of the situations. Here what is happening, number of common words is 1, and so that will mean that n will be what, 2 minus 1, that is 1. So n is knowing only one unique word that the second player doesn't know, and m is equal to also 2 minus 1, that is one word, one unique word, that is one word. The player 1 is also knowing one word that the other person doesn't know, and the player 2 is also knowing one word which the second player doesn't know. But also there is a common word, there is one common word. So who will win just quickly let me know in the chat. As player 1 started, as he play optimally, he can choose a word to say which are common. Okay, so that means that if it is common to both, right, so can I say that both will try to first of all conquer, both will try to first of all speak the common words, because here the game is dependent on the common words. Because if if you see these words, so these words are unique to both, right? The n number of words are unique to the first player by subtracting by the common words, after subtracting by the common words, and m number of words are common to the second players, right? So hi Ayush Tiwari. How's you? Okay, so n number of words, this much number of words are common to the first player uniquely, and this much number of words are common to the second player, but there are also common words, right? So both of them will try to get the maximum number of common words only, because in that case they can maximize their chances to win. Is this much part clear to everyone? Just quickly let me know in the chat. Is this much part clear to everyone? Okay. First one. Why the first one wins? Because what will happen in this case? Let me just draw a little quick. Okay. Right. So let's say that I give you, let's say the common word is 1, right? The common number of words is 1, n is 1. That is one word that is not known to the second player, and one word that is not known to the first player, right? So you always, the player will try, whichever player is there, either player 1 or player 2, both of them will try to go towards the common word first. They will try to first speak the common words out, so that the other player doesn't get more common words compared to him, right? So the first player comes in and player 1 will speak this word, right? So this common words now goes to 0. Now after that, what will happen? Since you have n is equal to 1, so what will you do? Like, this will be left, but now the player 2 will speak. What will he speak? No common words, so he'll have to use his unique words. He speaks up, and now his count becomes from 1 to 0, right? After that, your n is 1. So can the player 1 speak? Yes, player 1 can speak, right? Player 1 can speak. Now his count removes goes to 0, and the player two's chance comes in and he cannot speak, right? So the player 1 wins, so that is why you will print a yes for this case. Is this test case clear to everyone? Just quickly let me know in the chat if this test case is clear to everyone. Just quickly let me know in the chat. Is this test case also clear to everyone? Now I want to know the answers from all of you, that what should be the approach? How will you approach this problem further? How will you approach this problem optimally? Just let me know. Just quickly let me know. How can we find the winner? How to determine the winner? That is what I want to ask. Anyone can tell me? Anyone would like to tell me how to determine the winner? How would you determine the winner? Any answer from your side? How will you determine the winner? You have seen all the cases that can be possible. Now I want the answer from all of you. How do you think that we should, do you think that we should be approaching this game? We have talked about common words. We have talked about the number of unique words, right? That is n minus common words. Then m is equal to what? M minus common words as well. That these are the words that are unique to the first player, player 1, and these are the words that are unique to the second player. Now the situation comes in that there is common words, and both of them will try to maximize their common words usage, right? So first I will look for the common number of words and make it 0 first, and see which player the last common word sees, and then that is different. Okay, so you are saying this, you are saying, what you are saying, suggesting is that I will try whichever player gets in. So this is very much clear, right? This is very much clear that the number of common words that we are having, first of all we'll be using them, right? Whatever is the common number of words, both the players, what, let's say this is the common number of words. Let's say there are this much number of words, a lot of words, right? First player uses this, second uses this, third player uses this, like player 1, then player 2, player 1, then player 2, player 1, and then player 2, player 1, in this way, right? You are saying this. So both of them are trying to be alternative use of common words, right? Alternative use of common words. But how do you determine the winner still? Can someone tell me? How will you determine the winner in this case? How can we determine the winner? Can someone tell me? Is there any way that we can determine who is gonna win? How will you determine the winner? That is what I am asking you. Just quickly let me know in the chat. How will you determine the winner? Still, like, the concept, the approach is clear, but still, even when you are trying to be greedy, or you're trying to be optimal and you are using this common words, but still, how will you determine the winner even in this case? That is what I'm asking. Which player will be able to speak more words? Will the player 1 will be able to speak more words, or the player 2 would be able to speak more words? What do you think? Which player will be able to speak more words? Which player will be able to speak more words? This is what I want to know. Just quickly let me know in the chat which player will be able to speak more words. Shall I tell the answer, or anyone would like to suggest anything? Which player will be able to speak more words? That is what we want to know. Any answer from your side? Like Sethi, Ria, any approach? Just quickly let me know in the chat. Any approach from your side? Anything that you think that we could do? Just quickly let me know. Anything? Okay, so this guy suggests that there are common words, right? Right. If the number of common words is odd, then that means that, can I say that, if let's say if this is this, if it looks like this, 1 2 3 4, okay, let's say the player 1 speaks first, right? Then player 2, then player 1, then player 2, then player 1, and notice that there are common words are 5 words are common, assuming. So that means that player 1 is able to speak more than player 2. And how much is player 1 able to speak more than player 2? What will happen, this neutralizes with this word neutralizes with this word, so ultimately p1 is able to speak one extra word. Now let us see another case. Let's say that I have 4 words, right? In this case I have player 1, player 2, player 1, player 2. Which player is able to speak more? In this case I can say that the effective count of player 1, the effective count of player 1, that is n, increases by 1. Effectively n increases by 1 exactly, because all the others are getting neutralized. So that is why n becomes n plus 1 and m is same. Can I say this, that since the player 1 is able to take one extra chance if it is odd, so I will say that this will become n plus 1 and m will remain the same. Can I say this effectively? Can I say this? Just quickly let me know in the chat. Can I say this? If it is odd, if it is odd, then my n changes to n plus 1 and m is same. Is this clear to everybody? Is this much part clear to everyone? Just quickly let me know. This part is clear to everyone, right? Just write clear in the chat if it is clear, okay? Yes sir, effective number, yeah, effective number of moves increases by 1. If it is even, if what if it is even, right? What if it is even? The other situation will be when it is even, right? So let me just make some space for us. Okay, if it is even, what will happen if it is even? So if it is even, then player 1 player 2 cancels, player 1 player 2 cancels, so there will be no change, right? There will be effectively no change. Can I say that n and m both will be same? Both will be same. Can I say this? Can we say this? Is there any other thing? You just had to check for the common words, right? And before doing that, one more thing. Before doing that, this is not the value of n, right? The value of n will be n is equal to, let's say x is the number of words common, so n will be n minus x, m will be m minus x, right? And then you will, if it is odd, right, let me just make some space for us, then will remain same, yeah, right. But this is not the ultimate way, right? Because what will happen, let's say there are x common words, right? So what will you do? First of all, you subtract the common words, right? So n will become n minus x, that is unique to first player. M will become m minus x. Then if x is odd, then you increase n is equal to n plus 1, and then you check if n is greater than m, then first player wins, otherwise second wins. Is this clear to everyone? Just quickly let me know. Is this much part clear to everyone? Is this part clear to everyone? Just quickly let me know. Is this part clear to everyone? Just quickly let me know. Is it? Is this part? I can see a lot of people have joined. So in case if you haven't liked the video, you can consider liking the video as well. And you can comment down +1. If this much part is clear to everyone. Is this part clear to everyone? This part is clear to everyone. First of all, this is the number of unique words for the first player. Number of unique words for the second player is m minus x. Then if x is odd, you add. This part is clear. Okay. Shall we write the code for this? Shall we write the code for this? Okay. Let me open the IDE for this problem so that we can start writing the code. Okay, right. So let's begin ahead with this. Let me see the input format for this question first of all. So the input format is like this, right? Okay, so let us code down this problem quickly. If n is even, n and m has no effective change. Yeah, right. Okay, so only one test case will be there. I'll be taking long n comma m. Okay, after this what I'll do, I'll take n and m as an input. Once I've done that, I'm also declaring an unordered map. Notice this. I'm declaring an unordered map for the first value will be string and the second value will be int for this. Okay, why I'm doing this? Because to get the common words. We can do is, like, let me do this. You can not, it is not necessary that you do this, but still I am doing this. Okay, right? So let us do this. What will I do after this? What will I do? I'll simply take the first input, that is I start from 0, I is less than n, and I plus plus, right? And I'll take c in s, let's say string s. Let's say that I am taking a string s. Okay, I'll take the string as an input and I'll say map of s plus plus. That means that when this string comes, so I'll have to increment it, right? Everyone will agree to this, right? After this, when I get the second number, it is not necessary that you do it using map, but still I thought that map would be more convenient for us, right? If my this after this, I'll take the string input in this case as well, and if my current map of s, if it's not equal to 0, like if it is exists, right? If it is already existing, then in that case I'll say that I'll have a common, that is x is equal to 0, or let's say let's take it as common common, and let's initialize it as 0. What I'll be doing is I'll be counting the number of words which are common, right? Is this much part clear to everyone? I think it is, right? After this, what will I do next? I'll say n is equal to n minus the number of common words, and m is equal to m minus the number of common words. And after that, I'll check if the common words is odd. If it mod 2 is equal to, if it is odd, then I'll increment n by 1, right? This is what I'll do. And in the end, if my n is greater than m, right? Then I will say cout yes, and I'll change the line, else what will I do? Else I'll print a no. Everyone is clear with this much part? Is everyone clear with this much part? Just quickly let me know. I'm running it on so the sample test cases so that we are more clear about it. Making some mistake again, missing this I. Right, let me compile it again and see what happens. Okay, so it is giving me yes for the first case. Let me see for the second test case as well. Let's see what it gives for the second test case. If you haven't liked the video, you can consider liking the video if you are liking the explanation. So it gives a yes for this case as well. So for the second case as well, you got a yes, and that is what you should have got. Now for the third test case, let me just see that what we should be doing. For this you are getting a no. I think that it is perfect because it is running on the samples perfectly and we have thought about it a lot. Let me just submit this problem and see what happens. Meanwhile it is opening. Right, so let me just paste this and see what happens next. So the question has got submitted. Let us see whether it gets accepted or not. So it got accepted, right? You can see that the question got accepted. You can see this here. This question got accepted, and this was the most optimal way, right? Initially you will say that how do I approach this problem? This looks a bit complicated, but it wasn't. Notice that all you had to do was you had to count the number of commons, and I did it using an unordered map with the key as a string and the counter as int. And then if it was odd, then the effective number of words for the first player increases by 1. And simply I'll say yes if n is greater than m, otherwise I'll say no. Is this problem clear to everyone? Is this problem clear to everyone? Just quickly comment down below. Quite quickly, please comment down below if this problem is clear to everyone. Is this problem clear to everyone? Shall we move to the next problem? Shall we move to the next problem for today? Okay. Shall we move to the next problem? Next problem is more interesting, okay? Right. So let us move ahead with the second problem. The second problem is named as even odd game, and it was asked in CodeForces round 693, rated for division 3. So it was a problem D. It was the fourth problem in a division 3, which can be said as an easy medium problem. Okay, let's read the problem statement. So it says that during their holidays, Alice and Bob play the following game using an array A of n integers. So Alice and Bob are playing a game. Both of them are playing a game, and the game is being played using an array which consists of n integers. Alice will make the move first. As always, Alice will make the move first, and each player chooses any element and removes it from the array. So any player will be choosing any element and they can remove it. If Alice will choose the if Alice will choose the even value, if the array value, if the element that she has chosen, if it is even, then what will you do? In that case, Alice's score will increase by that much, that even value. Okay, let's say that if that even value is is equal to 2, so then in that case her score will increase by 2. If she chooses an odd value, then her score will not change. Similarly, if Bob chooses an odd value, then his score will increase, his score adds up, otherwise his score will not increase. Okay, this is what is happening. And Bob, if he chooses an even value, then his score will not increment. If he chooses an odd value, then his score will implement, right? Let us say that we have this case. If if no more numbers are left, then the game ends. The player with the highest score wins. The player with the highest score in this game will be winning. If the score of both players are equal, then the draw is declared. If both of the players are having the same score, then you will declare a draw. That is also clear. Now let's say n is equal to 4 and the array given to you is 5, 2, 7 and 3. Let's say this has been this is the array that has been given to you. Let me make some space for us. Okay, perfect. Let's write the array 3, 5, 5, 2, 7 and 3. 5, 2, 7 and 3. Okay, let's say if n value is 4 and the array is 5, 2, 7 and 3. In this case, what will you do? Let's say that you have these elements, right? What you can say is that Alice will come in. You will say that Alice comes in and you will say that Alice will pick this element up, right? Not this element, sorry. You will say that Alice picks this element up, right? You will say that Alice will pick this up because this is odd. So this is even, right? So Alice's score will be 5, will be 2. Alice's score will be 2. After that, you will say that Bob comes in and Bob picks this 7 up, right? After that, you will say that what happens next? You will say that Alice comes in and Alice picks this one up, but her score will not increase. After that, you will say that Bob comes in and he will pick this 3 up. So his total score is 10 and Alice's total score is 2. This is what you will do, right? Just let me know. Is this what you think that you will do? So can I say that Bob wins? Can I say that Bob wins in this case? Can I say this? Yes, I can, right? Is this much part clear to everyone? Just quickly comment down below. If this much part is clear to everyone, just quickly comment down below +1, and if you haven't liked the video, please like the video. Is this much part clear to everyone? Just quickly let me know. Is this much part clear to everyone? Is it? Right. Shall we move ahead? What you have to do in this case is, if Alice wins, then you have to say Alice. If Bob wins, then you have to print Bob. If there is a tie, then you have to print tie, right? This is what you have to do in this question. Now let us simply copy the test cases for this problem and see what will happen next. Okay, so I have copied the test cases and let me copy the answers with them as well so that we can keep on verifying our answers with the same. Okay, right. So let us move ahead with this problem and see what it has to say. As we discussed this case, that is 5, 2, 7 and 3. This was the case that we discussed, right? Just above. This was the case 5, 2, 7 and 3. This was the case that we just discussed. Now let us move to the next case, right? In that case, Bob will simply win. But what will happen if, let's say, n is equal to 3 and the array is given to be 3 to 1? Then in that case, what will you do? In this case, what will happen? If the array is 1, 2 and 3, let's say the array is you can say 3, 2 and 1. In this case, what will happen? What will happen in this case? You will say that Alice comes in and Alice chooses this. You will say that Alice chooses this. So Alice will get 2. After that, you will say that Bob comes in and Bob will choose this 3 up. So you will say that Bob gets 3. Now you will tell me that Bob will come in, right? You will tell me that Bob comes in and Bob chooses this. You will say that Bob chooses this. Not Bob, but Alice. You will say that Alice comes in and Alice chooses this. Her score will not increase. Her score will not increase. But what will happen is that her score will remain the same, right? So that means that you will say that Bob wins. You will say that Bob wins. Is this the case? Is this does everyone agree on this, that you will say this for this test case? Everyone agrees on this part? Just quickly let me know. Is this the case? Both players are playing optimally, note that as well. Is that the case for this problem? That is what you will do? That is what you will do? Is it? What will you do in this case? I just want to know your answers. I just wanted to know your answers quite quick. What is your answer? What is your take on this? Is this how this problem can be done, or will you do it another way? How will this problem get solved? Just quickly let me know. Yes, agree, but Alice can also pick odd element. Yeah, right. Okay, let's do one thing. Let's do one thing. Let's first of all segregate, right? Let's say that I have some cases. Let's say I have some 6, 7, 8, 9, 1, 2, 3, 4, 5. Yeah, right. Let's say I have these numbers. So what are the even numbers that I am having? I am having 6 and 8 as even, and I am having 5, 7 and 9 as odd. What will happen in this case? Who will win? Can you tell me? Who will win? For this case, who will win? Can you tell me? Just quickly let me know. What is your answer by looking at this case? What do you think that is the player who is going to win? What do you think is will be the player who is going to win for this case? Any answer for this? What do you think? Who is the player who is going to win? Just quickly let me know. I'm still waiting for your replies. Who will win? For this case, who is going to win? Which player is going to win? Any answers for this? Any answers for this case? Which player is going to win? Just quickly let me know in the chat. Which player is going to win? Bob. Okay, one answer has come that Bob is going to win. Okay, let's see who will win. Um, for this case, let us say who will start first. Alice will start first, right? Alice will come in, and now let me make some more. Let me make some space so that we can perform it in a better manner. This is 1 and 8, and this is 5, 7 and 9. What will Alice do? If Alice knows, if you play traditionally, then Alice will lose, right? But what will happen? Let's say Alice will not choose this number, right? Alice will choose this. Why? Because she will want, if she can see that she cannot win, right? Since she can see